Okay. Okay, welcome to this physics second question, which is the electricity topic, and it's lesson 2. Okay, so under this question, get closer. Under this question, we have seen the diagram. So diagram, we have got 12 volts. The cells are 12 volts. We have got R1, we have got R2, we have got R3, and we have got R4. Get it closer. So now in this case, we have got all this. So let's come now to question 1, the first question. The first question now is calculate the combined resistance of R3 and R4. So in this case, we are going to calculate combined resistance for R3, which is this one, and R4, which is this one. So let's now calculate now. So now, as you can see here, we are going to do like this. I'll use the simple formula, which is hala total resistance is equals to R3 times R4 over R3 plus R4. So in this case, we are going to substitute. What's R3? R3 is 6. So it will be 6 times R4 is what? 3. 6 times 3 over 6 plus 3. Okay. So now, 6 times 3, what's the answer? 6 times 3, the answer is 6 times 3, the answer is 18. Over 6 plus 3, the answer is what? 9. So now, 9 into 18, the answer is 2. Units for resistance, its resistance is ohms. So the answer is 2 ohms. Okay, I've done this first question. Let's now shift on to the next question. The next question reads as follows. Calculate the 2 ohm and 4 ohm resistors in series. So we are going to calculate now the what? We are going to calculate the 2 ohm and 4 ohm resistors in series. Okay, and these are the ones we have seen, 2 and 4 ohms. These are the ones. Okay, so now let's come and calculate this one. So for resistance concerning series, we use this formula. We say RT, which is total resistance is equals to R. This is R1, so this is R1. So R1 is this one, so we're going to say R1 plus R2. So now in this case, what's the value of R1? The value of R1 is 2. So we write 2 here, plus, what's the value of R2? The value of R2 is 4. So we write 4 here. Okay, so you have seen now we have substituted, which is R1, 2, and R2, 4. So now, the question now is 2 plus 4. What's the answer when you say 2 plus 4? The answer is 6. So I'm going to write 6 ohms. Okay, so we have done also this calculation, which is calculating the resistance of R1 and R2, which are in straight line, which we call series. Okay, let's now come now down here. So down here we have a question saying that calculate the reading of the ammeter. Calculate the reading of the ammeter. Where do we have the ammeter? Let's go on to the diagram. Let's go and check. The ammeter, it's here. This is the point of the ammeter. This one. This ammeter is used to measure current. So now, what's the reading? So it's connected to parallel. So we are going to calculate. So let's come and calculate now. So in this case, we are going to say that voltage is equals to current. For voltage is equals to current times resistance. Let's come now and calculate. So I'm going to say voltage is equals to current times resistance. So in this case, we say voltage, because there we are looking for current, right? So what's the voltage which is given in this question? The value of voltage given is 12. So we write down 12. So 12 is equals to then current times resistance. So we have calculated the combined resistance, which is 2 ohms. Have you seen? In parallel, it's 2 ohms. We have calculated 2 ohms. So I'm going to put here 2 ohms. Press the camera. Okay, 2 ohms. So now we say 12 is equals to 2 times I is 2I. Then you're going to say over 2. This 2 into 12 is 6. So current is equals to 6 amps. So you have seen how we have calculated the current here in what? The current, this is current 1, which is passing through this. So we have calculated current 1 as 6 what? As 6 amps. Okay. So now let's now go to the next question. Question C. Question 3 is as follows. Determine the potential difference across the 4 ohm resistor. So potential difference across 4 ohm, the 4 ohm resistor. So potential difference is same as voltage. So I'm going to calculate voltage here now. So I'm going to say voltage is equals to IR. So now they are saying that voltage across what? Across the 4 ohm. So how are we going to calculate the voltage for this one? So we're going to do like this. We're going to say our voltage is equals to, of course we know the value of R because we are going to use 4R. But in this case we don't know the current which is circulating in this circuit. So now let's do this. We are going to say, we are going first to find the current which is flowing in that other circuit. So we're going to say that number 1 is first find the total resistance. So we're going to say total resistance RT is equals to R3 R1, I'm sorry. So I'm going to say RT is equals to R1, 2 times R3, 4. So we are getting them there. Okay, we are getting them there. In this case, we are saying that this is one resistance and this is one resistance. So I'm going to say RT is equals to R1, 2 times R3, 4. Then we say over again the same R1, 3 times plus, in this case it will be now plus R3, 4. So now it will be now R1, 2, the value is, we have calculated 2 times R3, R1, 2, the value is, for R1, 2 is this one, R1, 2, the value is 6. So we say 6 times, then R3, 4, the value is 2. So we say over over 6 plus 2 over 6 plus 2. This is equals to 6 times 2. What's the answer? 6 times 2. Closer, get closer. 6 times 2. What's the answer? 6 times 2. The answer is 12 over 6 plus 2. The answer is what? 8. 6, 7, 8. Then now we say 8 into 12. 8 into 12. Okay, so we are going to reduce this. We'll say 2 into 8, it's 4. 2 into 12, it's what? 6. Then now we say 2 into 4, it's 2. 2 into 6, it's 3. So we'll say 2 into 3, the answer is 1. Remainder 1. 2 into 1, it can't. We are going to write a decimal point. Then we had a 0. 2 into 10 is 5. So it's 1.5 ohms. This is the resistance, the total resistance. So this total resistance, we are going to use this to calculate now the total current of the circuit. So total current of the circuit now, in this case, let's use this paper. We are going to say total current is equals to voltage over resistance. So now voltage is 12 volts. 12 volts over total resistance, which is 1.5. So 1.5 into 12. The answer is 8. The answer is 8 amps. The answer is 8 amps. So in this case, we are going to now find the current flowing in the second loop. So this loop we have seen, this is current 2, and this is main current. So current 2 now, we are going to say main current is equals to current 1 plus current 2 plus current 2. So here we are going to say this. The main current is 8. The main current is 8. So 8 is equals to current 1. Current 1 is, we have calculated current 1 as 6 amps. So 6 amps plus I2, which is current 2. So now we're going to say 8, this one will cross the equal sign, will come this side. 8 minus 6 is equals to current 2. So in this case, we'll say 8 minus 6, the answer is 2 amps, is equals to 2. So we say current 2 is equals to 2 amps. 2 amps. So now in this case, we can now come and substitute here. Here now we're going to say voltage is equals to current which flowing at in this circuit. Current flowing in this circuit is 2 amps. So I'm going to write now 2 times resistors at 4. Resistors at 4, this one, it's what? It's 4. So we are going to say 2 times 4, the answer is what? The answer is 80 volts. The answer is 80 volts. So in this case, at resistors 4, the voltage is 80 volts, which you have seen here, which you have calculated. Camila. Okay, which you have calculated. So this is the answer for this question. As you can see, this is the whole question that we have done. Okay. So we have done this question and we have finished. So I invite now you in the next question. See you in the next question.